Now our lecture today is so easy. So excuse me, focus with me. Today we'll talk about how we can write linear equation as a vector equation. Okay, so here we have definition of vector. This is main vector, and this is the elements of these vectors. So this is W big W, and this is W1, W2 as elements of this vector. Okay, I need from this picture to focus out how we can write. This is I guess you studied something before about how we can write the vectors. I need to focus about also you said this at physics, how we can, for example, add two vectors together. I don't need this. I will go here from this one. Yes. First definition today is this one, linear combinations. What is the linear combinations? See here, x1, a1 plus x2, a2 equal b. This is called linear combination. So this is a, this is b or a2, and this is the b. So if we have like this equal this, we can say it's linear combination. Okay. I will rewrite something again. This one, I see this one. See, in vector, I will open the from now directly to just a minute. Okay, now let's make conclusion. I have now linear system. For example, a1, x1, positive, a2, x2 equal b1, a2, a3, x1 plus a4, x2 equal b2, a5, x1 positive, a6, x2 equal b3. This is linear system as we studied before. We can write this one in two forms, vector form or matrix form. This is for next week, by the way. So today I will combine two lectures together. How we can write matrix form? First of all, isolate x. This is x1. This is x2. In vector form, see my hand arkadaşlar. I will take those as vector a1, a3, a5 plus this one as a vector a2, a4, a6 equal this one p1, p2, p3 equal. Then here I have x1, x1, x2. So as you see, it's so easy. So easy. This is what we can say vector form. So I have a1, a2, a3 as a vector, a2, a4, a6 as a vector equal b1, b2, b3. Now, what about matrix form? Matrix form, let's use this one. It's a matrix. It's an AX equal B. What is AX equal B? This one. A is this a matrix. See, A matrix. It is A1, A2, for example, A3, A4, A5, A6. Multiply X1, X2, for example, here. If we have X3, we can write X3 equal P1, P2, P3. Here, if I want to write like what you know, here we missed something. If you want, if we have three matrices that we have three variables. So let's, excuse me. So let's make like what you know. A3, A1, A2, okay, 6, 7, 8, A9. X3, X3, X3 equal P1, P2, P3. So here we can change also. I will rewrite plus A2, A4, A6 plus A7, A8, A9. Here we have X2, X3 equal this one, P1, P2, P3. Here, if I want to refine this, I will add this one, A7, A8, A9, dot X3. So if I have three variables, I have three equations. As you see here, just we are changing the form. It's a form. So in vector form, we have A1, A2, A3 in a vector. For example, 2, 4, 6 in the vector, A7, A3 in the vector. In matrix, as you see, it's A1, A2, A3, A4, A5, A6, A7, A8 in the one vector, or in the matrix. Multiply X1 here, equal to B1, B2, B3. Okay, so this is the two forms. So sometimes, inshallah, we'll see later, we have linear system equations. They will ask me write in vector form or write in matrix form. So this is the vector form. This is the matrix form. Any question about two forms? Okay. Take photo for this from the internet or from the, inshallah, after finish, and keep this in your brain because we're gonna use this more. Now let's return back to our book. Here. For example, here, as you see here, we have just common equation. We have equation 1, equation 2, equation 3. But how many variables? Two variables. I wrote this before, but I want to make, John, but we know from high school, if we have three matrices, then we have three variables. Yes, I know, but this is the second case. We'll explain this one now in details. That means if I have three variables, I need three equations. That's mean to give me one, or there's one solution. But here sometimes, as I informed you before, we have solution, we don't have solution, or we have many solutions. Okay, now let's go ahead for this one and see. This is vector form. Now, I will go to the matrix form. This is matrix form. Or if I want to refine, I will write like this, it's equal, or x1, or let's refine, it is 1, 2, minus 2, 5, minus 5, 6, multiply x1, x2, equal 7, 4, minus 3. And this is also the equation form. So now in our lecture today, we talked about equations form, vector form, matrix form, how we can jump from one to others. Okay. How we can solve? We can solve, as you see here, based on augmented matrix. So again, for first look, see this one. Here I have two variables, but I have three equations. So you must here think that's me. It's not one solution or unique solution. Here we have another thing. Either one so many solutions or there are no solutions. But here I have a 3. Where is x3? We don't have x3. Where is x3? This is x1. This is x2 here. Where is x3? We don't have. So you have to think that it's free variable. Let's see the answer if I want to write the augmented matrix. To solve this system row, reduce the augmented matrix. So I wrote here the augmented matrix. And I solve it as I told you before. Now let's see the last row. This is, this is x1. This is x2. This is x3. So x3 here is a free variable. x3 here is a free variable. Now, he will ask me if it's linear combination or not. You can select any number for x3 and put in this one to check if it's a free variable or not. x1 here is 3 if you solve. x2 is 2. Return back after solving. This is from the previous lecture. Return back, put here 2, put 3 and check. If this one after solving equal this, so we can say it is linear combination. Conclusion. We can write equation form or linear algebra equation form in equation form or vector form or matrix form. Linear combination means that I have to solve this system. How can I solve based on my augmented matrix? Then find x values. Then put x values in the formula. After that, check if equal right. Repeat. Linear combination, I have to check if left equal the right. So first of all, you have to solve. How can I solve augmented matrix? I informed you before. Then find x values. Then put in the formula. If left equal right, so we can write its linear combination. Is it clear or repeat? Is it clear or repeat? Yeah, I am with you. Now, let's try to solve this example. This is example 6 about this is cancelled. Example 6 is cancelled. This is cancelled. I will open the book and start to solve some examples from your book. Where's the book? Just a minute. Just this book. Yeah. One is go to the vector form and return back to the questions. Yeah. Now, in exercise 5 and 6, write a system of equation in the write a system of equation that is equivalent to the given vector. He asked me write a system of equation. So here I have to convert from vector to system. How can I do this? Easy. It's equal. Here x1, so 6x1 minus 3x2 equal 1. This is minus x1 positive 4x2 equal minus 7. 5x1 plus 0 equal minus 5. That is, it's hard. So here I converted from vector to the system. If he asks me write as a matrix from vector to matrix, so it's easy. It is 6 minus 3 minus 1, 4, 5, 0 dot. I have two variables, x1, x2 equal these 1 minus 7 minus 5. Is it hard? Now here I convert from one system to another system. Okay, now another question. So 5, 6, okay, it's easy. Now let's go to the question number. In 9 and 10, write the vector equation that's equivalent. He gives to me here system and asked me write as a vector. So I guess now it's easy. Now, this question. In exercise 11 and 12, determine if B is a linear combination of A1, A2, A3. Let's solve together. Take this, solve together. Okay, where is this? Here. Together, let's solve. Determine FB. Determine, that means solve. So I will write first thing. One, write augmented matrix. So this is augmented matrix 1, 0, 5, 2, minus 2, 1, minus 6, minus 1, 0, 2, 8, 6. Then I want to write as augmented matrix, then solve. So this is the main diagonal. It should be 0. So let's solve together. 2 R1 plus R2 in R2. It's 1, 0, 5, 2. 2 with 2 is 2, 0. 2 with 0, 2 here, 1. 2 with 5, it is 10. It's 4 minus 2 with 2, it is 4. With 1, it's 3. If it's wrong, tell me, excuse me. No change here, 0 to 8, 6. Is correct? Now continue here. I have 0, 0. I want to cancel this. So R3. This is the previous lecture. Return to the video. Who followed me in the previous lecture can understand this. I will not repeat the lecture, full lecture. Okay, sir? Return to the previous lecture, you can understand this. I asked you to follow me about these numbers. 1, 0, 5, 2, 0, 1, 4, 3. Here. No, here I need 2. 2 are 2 in minus. 2. With minus 2, it's 2, 0, 0. Now minus 2 with 4, it is minus 8 with 8, 0. Minus 2 with 3, it's minus 6, it's 0. As you see here, x3, this was x1. Return to the previous lecture. This is x1, x2, x3. x3 here is free variable. So you can select any value for this one. After that, you can find x1 and x2. So here, I will write this x2 positive 4, x3 equal 3, x2 equal 3 minus 4x3. If x3 select, for example, 1, x2 equal 3 minus 4, it is minus 1. It's 2, sorry. Now find x1 here. x1 positive 0, x2 positive 5, x3 equal 2. This is bye-bye. x1 equal 2 minus 5, x3. Here, for example, x3 is 1. So x1 is 2 minus 5. It is minus 3. Now let's take these values and put here. Linear combination. This is, that means x1 a1 positive x2 a2 positive x3 a3 equal b. This is linear combination. So here I will select x1 here. What is it? Minus 3. x2 is minus 1. And I guess this one. Okay, minus 3 with 1, it is minus 3. Here 0. Here 1. With 5, it is 5. Minus 3 with 5 equal to, yes. So we can write it's linear combination. Got it? It's clear for you? I guess not clear. So first of all, I wrote augmented matrix. Second thing, I saw the augmented matrix. Here, for example, I have 3 variables. Select any variable. Then find x2, x1, then put in the equation and check. You can check just one element. It's enough for me. Let's book it. So this is exercise 11, how you can solve this exercise. How we can solve this exercise. Okay, so it's linear combination, yes. So now I have a question. If there is no solution, so there is no x, so just write no x, that means it's not linear combination. So if we have one solution, it's okay. If we have solution, now for example, free variable, select any variable for x and solve. If there is no answer, or there is no variable, no answer, just write there is no answer and it's not linear combination. Okay, any question for this? Guys, where is, this is x2. Is it clear? Hamid, this is x2, got it? Yes, minus 1. Minus 1. Again, excuse me, at home, try to solve this example, see this video, and try to solve this example by your hand. Okay? Any question for this? So where x3 is a free variable, select any number for it, Jamal. Jamal, x3 is a free variable. See here, x3. Jamal, see this. This is 0, 0, 0, 0. That's mean free variable. So here, select by yourself. Okay. It can be 0, but I don't prefer 0. It can be 0. Jamal, it can be 0, but try avoid. Okay. Any question for this? Is it clear? Okay. Now let's go to your book. In exercise 13, 14, determine if P is linear combination. Same question here, but here I used, or I'm using now here, the matrix form. Okay, sorry. Copy. Here, Control A, delete B. Same question. Determine, that means solve. So first of all, write augmented matrix. 1, 3, 0, 3. Solve. This is ready. This is ready. Okay, I need this. So this is solved. I need now this. These are done. R3, R3 with 2 R1 bus. This is ready, so it's 1 minus 4, 2, 3, 0, 3, 5, minus 7, 2 with 2 here is 0, 2 with minus 4 it is 8 here 0, 2 with 2 it's 4, 0, 2 with 3 it's 6, 2 with 3 it is 6, with minus 3 it's 3. Good. Let's check again. 2 with 2 it's 0, 2 with minus 4 minus 8 0, 2 with 2 it's 4, 4 it's 0, 2 with 3 3. See here answer. Last row it is 0 0 0 3. That's mean 0 x1 plus 0 x2 plus 0 x3 equal 3. So ignore this. I focus on this one. 0 x3 equal 3. That's mean x3 equal 3 over 0. Is this correct? Jamal, Muhammad, Barto, is this correct? No. So exactly. Thank you so much. No answer. Finish. So no answer and stop here. That is yes, 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 yes. No answer. Traditional no answer. How you can find answer? 3 over 0, it's not defined. So answer, no answer. Stop. Got it? So now we solved two cases. One is a free variable. Second case is no answer. Any question for this? Any question for this? Okay. Now let's close this. Bye-bye. Close this, and return back to the book. Question number 15, 16 is cancelled. I need it from you. I need to solve in your book. This is 1.3. Solve 5, 6, 9, 10, 11, and 12, 13, 14. Repeat. In exam, you are responsible for these. 5, 6, before this and this, this and this, this and this. Others cancelled. Is it clear?